All right. Now let's go to our next question. Question number 16. It says, industrially ammonia is made by the Haber process. The equation is given. The condition used are 450 degrees centigrade and 200 atmospheric pressure. Now, which statement about the conditions are correct? We have been given number one choice, where the temperature below 450 degrees centigrade gives a lower rate of reaction. The temperatures between 450 degrees centigrade give a lower yield of ammonia. Choice 3 is pressure above 200 atmospheric pressure gives a lower yield of ammonia. And number 4 is pressure above 200 atmospheric pressure are too expensive to maintain. So our choice is B, statement number 1 and 4. Statement number 1 says temperatures below 450 degrees centigrade gives a lower rate of reaction. And number 4 says that the pressure above 200 atmospheric pressure are too expensive to maintain. Now let's see the explanation to this question. It says operating the Haber process at a lower temperature slows down the rate of reaction because particles collide less frequently and with less energy. Additionally, maintaining exceptionally high pressure requires specialized heavy duty equipment that is highly expensive to build and operate. All right, now let's move on to our next question. Question number 17. It says ethanol is warmed with acidified aqueous potassium magnate 7. Which row describes the type of reaction of the ethanol and color change observed in the reaction mixture? So we have been given a table again. For the first heading, we have type of reaction given. For the second, we have a color change. So the options given are oxidation type of reaction, where the color changes to purple, colorless to purple. And the option B is given, where type of reaction is oxidation, purple to colorless. Option 3 is given, where the type of reaction is reduction, color changes colorless to purple. And type of reaction, number D choice is reduction, and color changes purple to colorless. So our choice is oxidation and purple to colorless, which is option B. The reason behind is the acidified potassium magnate 7 acts as a powerful oxidizing agent that oxidizes ethanol into ethanoic acid. During this redox reaction, the magnate ions are reduced, causing the solution to change color from purple to colorless. All right, now let's move on to our next question, question number 18. It says two experiments involving acids R or S are done. So, first, we have been given that 0.10 mole of acid R completely dissolves in 500 centimeter cube of water. Then 0.0048 mole of acid R is dissociated in the solution. All right. Next, they are giving us that 0.10 mole of acid S completely dissolve in 500 centimeter cube of water, where 0.0179 mole of acid S is dissociated in the solution. So, which statements about the acid R and S is correct? Our choices are acid R is a strong acid and acid S is a weak acid. Number B is acid R is a weak acid and acid S is a strong acid. Number C, acid R and acid S are both strong acids. And number D is acid R and acid S are both weak acid. So our choice here is option D. It says acid R and acid S are both weak acid. The explanation to this logic is that both acid R and acid S dissolves completely in water, but show very low level of dissociation into hydrogen ions. Because only a small fraction of the dissolved molecules from ions, both substances are classified as weak acids. Alright, now let's move on to our next question, question number 19. It says lead 2 sulfate is an insoluble salt. So which process is not used to prepare a pure sample of this salt? Okay, so we have method given, option A crystallization, option B drying, option C filtration, and option D precipitation. Our answer choice is crystallization. The reason behind is that lead 2 sulfate is an insoluble salt that is prepared through a precipitation reaction between two soluble salt solution because the product forms as an insoluble solid rather than a dissolved solute. Crystallization cannot be used to isolate it. That's the same thing that they're asking us, that which process is not used to prepare. Okay. All right, let's move on to our next question. Question number 20. It says the formula of two hydrated salts are shown. Okay, this is copper sulfate and then NaClCl2 with water attached. So, what are the values of X and Y? Our answer choice is B, where X is 5 and Y is 6. So, the explanation to this is that hydrated copper 2 sulfate crystals contain 5 molecules of water of crystallization per formula unit, giving X a value of 5. Now, hydrated cobalt 2 chloride crystals characteristically bind 6 water molecules, giving Y a value of. Alright, let's do our next question, question number 21. The properties of elements change from left to right across the periodic table. So, which statement describes how the properties changes across period 3? So option A is elements changes from gases to solid. Number B, elements change from non-conductors to electrical conductors. Option C, elements change from metal to non-metal. And option D, elements have decreasing number of electron shell. Out of these four options, our correct option is C, which is element change from metal to non-metal. So what's the logic behind? Alright, so moving left to right across period 3, the elements progress from highly reactive metals on the left side to the reactive non-metals on the right side. This chemical transition concludes with the unreactive noble gas argon at the far right of the period. Alright, let's move on. Question number 22. It says which property decreases down group 7 of the periodic table from chlorine to iodine. So which property? The options are given. Option A, atomic number. Option B, density. Option C, reactivity. Option D, melting point. So our answer choice is C, which is reactivity. The simple explanation to this is, as you move down group 7, the atomic radius increases, which places the outer shell further from the positive pull of the nucleus. This structural change makes it more difficult for the atom to attract and gain an electron, decreasing its chemical reactivity. Alright, now let's move on to our next question. Question number 23. It says some properties of elements are listed here. Number 1, they have good electrical conductivity. Number 2, they have high melting points. Number 3, they are malleable. And number 4, that they have ions with variable oxidation numbers. So now we have to choose like which properties are correct for both iron and lithium. Our correct answer choice is A, which is 1 and 3. So they have good electrical conductivity and they are malleable. Now the explanation to this for iron and lithium is iron and lithium are both metals, meaning they naturally possess high electrical conductivity and are highly malleable. However, lithium is an alkali metal with a relatively low melting point and a single fixed oxidation number of +1, unlike transition metals. Okay, now let's move on to our next question, question number 24. So it says here two statements about noble gases are listed. Noble gases are reactive, monatomic, and number 2, noble gases all have a full outer shell of electrons. So which statements about the noble gases are correct? Option A, both statements are correct and statement 2 explains statement 1. B, both statements are correct, but statement 2 does not explain statement 1. C, statement 1 is correct, but statement 2 is not correct. And option D, which is our answer, statement 2 is correct, but statement 1 is not correct. So noble gases are reactive, monatomic gases. This is a wrong statement. The explanation to this is noble gases possess stable completely full outer electron shells, so making the statement 2 entirely accurate. Because of this inherently stable configuration, they exist as monatomic gases and are extremely unreactive, making statement 1 incorrect. Okay. Now let's move on. Question number 25. Which statements about the properties and uses of copper is correct? Okay. So number one, option A given, it is used in electrical wiring and it is ductile. This is the correct statement. Copper is used in electrical wiring and it is ductile. Statement B, it is mixed with tin to make the alloy brass. Wrong. It is used in overhead electrical cables because it has low density. Again wrong. It is used in takeaway food containers because of its resistance to corrosion. Again, this statement is not correct. So our explanation to answer choice A is it is used in electrical wiring and it is ductile. The explanation is that copper is highly ductile metal, allowing it to be easily drawn out into long, thin wires without fracturing. Combined with its excellent electrical conductivity, this mechanical property makes it ideal for manufacturing electrical wiring. All right, now come on, let's go on to the next question. Question number 26. It says three statements about solid Z are listed. Okay. Now the name of the solid is not disclosed, but their properties is. So first property is it reacts with dilute hydrochloric acid to produce hydrogen. Number B, it reacts very slowly with cold water and quickly with steam. And then it is a good thermal conductor. So we have to identify that what is solid Z. Is it a gold? Is it a magnesium, potassium, or silver? So our answer is B, magnesium. The reason behind is magnesium metal reacts rapidly with steam to form magnesium oxide and hydrogen gas, but it reacts incredibly slow with cold water. Additionally, it is a metallic element, making it an excellent thermal conductor that reacts with acid to release hydrogen. All right, let's move on to question number 27. Okay. So it says, question number 27, four metals J, K, L, and M are added separately to aqueous solution of their ions. The results are shown. As you can see in the table, we have an aqueous ions J 2 plus, K 2 plus, L 2 plus, and M 2 plus, and the metal J, K, L, M given, and then the right and wrongs are given. The key right means reaction and wrong means no reaction. So which statement about the metal is correct then? J has a greater tendency to move from positive ions than K. Now this is our correct answer, and the logic behind this is metal will displace another metal from an aqueous solution if it is more reactive and has greater tendency to form positive ion. So since metal J is successfully reacting with the ions K, L, and M, that you can see here in the table that K, L, and M all are right, okay? So it is the most reactive element in the group. So others are other options are L has greater tendency to form positive ion than J. This is wrong because you see there is only two ticks. Okay, likewise other statements are also not correct. So our answer choice A is correct because J is reacting with more ions and metals. Okay. All right. So let's do our next question. Question number 28. Which process is used in the extraction of iron from hematite? So, all right, here the options are number A, electrolysis, number B, precipitation, number C, reduction, number D, fractional distillation. So, our answer choice is reduction. Reduction is used as a process in the extraction of iron from hematite. The logic behind is that hematite consists primarily of iron oxide, where the iron exists in an oxidized state. Extracting pure iron metal requires a reduction process inside a blast furnace where carbon monoxide removes the oxygen from the iron ore. Alright, now let's move to our next question. Galvanizing prevents iron from rusting. Okay. So, which statement about galvanizing is correct? Number one, galvanizing involves coating the iron with silver. Galvanizing prevents oxygen and water from coming into the contact with the iron. And option 3 is galvanizing works because the metal coating loses electron more rapidly than iron. So out of these three statements, we have been given some choices that which is correct here. So option number C is correct. Only 2 and 3 statements are correct. So this one, the first one, galvanizing involves coating with iron and silver, is completely wrong. So the explanation to see is galvanizing involves coating iron with protecting layer of zinc, which physically blocks oxygen and moistures from reaching the underlying metal. If the surface is scratched, the more reactive zinc acts sacrificingly by losing electrons more readily than iron to prevent rust. Alright, let's move on to our next question. Question number 30. Alright, so here it says nitrogen, phosphorus, and potassium are essential elements for improved plant growth. Which mixture provide these three essential elements? So our answer choice is ammonia, ammonium phosphate plus potassium chloride. Ammonium phosphate plus ammonium nitrate, option B is wrong. Ammonium phosphate plus ammonium chloride also is not correct. And ammonium nitrate and potassium chloride also is not correct. So our answer is ammonium phosphate plus potassium chloride. Option A. The explanation to this is that ammonium phosphate provides essential nitrogen from its ammonium ions and phosphorus from its phosphate groups. Combining these compounds with potassium chloride introduces the third essential plant nutrient, which is potassium.